For this video, we're going to depart a little bit from the Think Python book and look at try except commands and how they can be used to handle errors. And we've already done some of this, but I'm going to try to formalize it a little bit. So the first example is one I think we've seen before. It's been a little while though. So we have two numbers that we're going to put in and try to make a fraction, a numerator and denominator. So we'll input those. Remember, when we input those, they come in actually as strings. All inputs through Python are strings. So what I want to do is convert these to an integer, but when you have a user inputting data, you always want to validate that they have actually typed in what you hope they would. So I'm looking for a numerator, but what if the user decides to type in their name for some unexplained reason? Then when I go to convert that to an integer, it's going to fail and the program's going to crash. So you want to try to handle these kinds of cases. So the way to do this in Python is to use a tryexcept block. So I'm going to try to convert these to integers and then try to set it up as a fraction. So I'm going to divide, well, actually it's a decimal. I'm going to divide x by y. And there's two kinds of errors that can occur here then. An error can occur in the conversion to an integer, and an error can occur if we divide by 0 here. And they generate two different kinds of errors. The first, converting to an integer, if you actually try to convert a string to an integer, you get what's known as a value error. And then the other one is simply a zero division error. Okay, so if all of this is successful, then I will have successfully computed div, and at the end of this, right here, I know I've successfully computed div, so I can print div out. Otherwise, if I get a value error, I know that I must have, the user must not have put in an integer, so I'm going to print out a little message saying, hey, you got to put a number in, and if they actually put in a 0 for the denominator, I'll say, no, you can't do that. So let's run this. And I'm going to put in my name, and it just says you must put in numbers. I mean, I could have put in a little more descriptive error messaging, but and if we try to divide 0 by 0, you find out that you can't divide by 0. And then finally, I put in 2 and 1. Then that stays inside the try. The try is successful, and so it executes the code here. All right, now let's look at a little better version maybe of validating input. So suppose that I want to input either an integer or a float. So I wrote some subroutines to handle this, and I actually have 4 here. It's maybe a little bit of overkill. This one, input int once, goes out and asks for an input, and then it tries to convert it to an integer, and if it fails, it prints out you must put in an integer. But it only tries to do it once. Now, what I should point out here is that this s is actually a string that we can pass to that program. So if we want to input an integer, we'll just simply pass a string input and integer. Okay, so input int once, again, gets the input, tries to convert it to an integer, and if that doesn't work, prints out you must put in an integer. Doesn't accept the value they put in. Instead, it returns a none. Otherwise, we return the valid integer. Input int, which is the thing that we actually call, just keeps calling input int once until it gets a valid integer. So we pass in that string. We pass that on again to input int once. And then we just have this while loop. We start off with x equaling none, and while x is none, we just keep calling this input int once. And if you get value errors, it just keeps x at none and just keeps going and going and going until you actually get an integer, and then x is no longer going to be none, it'll be that integer. You exit the while loop, and you return that integer value. input float once and input float are the exact same thing. The only difference is we convert to a float here. And so let's run this. I'm going to type in an S. And that S is going to put us in the except. So we should get input, and you must input an integer, and it's going to return none back to input int. So there's the input and integer. And since it returns a none, x is equal to none, this while loop continues to execute. So we call input int once again. We try to put in another integer. I'll put in 2.0. Again, it doesn't work. We get a value error. X is still none. We call input int once again. So let's put this thing out of its misery and actually put it in an integer. So this will just keep going and going and going until you actually get a valid integer entry. So this is one way you could guarantee that the user is going to type in the kind of value that you want. So if you were looking for something like a street address or a social security number or something like that that you know is made up of integers, then you want to make sure that you get the right kind of data in there. There's no data entry errors. I mean, there can still be errors, but not silly kinds of errors. Now, the only thing I didn't like about this, so the next bit is getting away from the whole tryexcept block. So I hope that you have the idea of how the tryexcept block works. If you have code that could generate an error of some sort, so a conversion to an integer or some other kind of thing, then you can try to trap that error if you have a way to handle it or want to handle it, instead of just having the program crash. So the one thing I didn't like about this was I ended up with 4 different functions here, one for integers and one for floats, but the code is identical. The only difference is that here I'm calling float instead of integer, and down here input float once instead of input int once. So it just seemed a bit silly. So we got a little fancier and fix this up so that there's only 2 procedures. And the way this is going to come now is I'm going to input a number. This is the string, so in this case I want to input a float. And then this is the type of number that I want. So this can be either integer or float. And as you notice, I actually have the word complex here. So this is saying a complex number. I'm doing this on purpose because this is actually going to generate an error of its own. So then we have input number. This is the one with a while loop. So x is none, while x is none. We try to input a number once. And this now has a tryexcept block in it with a key error. So this is something new. We'll go up and we'll see what the key error is. Basically, the key error is what happens if I try an invalid number type. So here I'm trying a complex statement, and that's not a valid number type, so that's going to generate a key error. And in that case, that's the program that's screwing up, not the user, and we are just going to return none and be done. Okay, so otherwise, we are doing input number once, and we are again passing in the input string, input a float, and the number type. So let's look what happens up here. I've defined a dictionary, and the dictionary has 2 strings, int and float, and then associated with it the command int and the command float. So I'm going to return number types, num type, input, string. So I input the string, and then number types, num type. So if num type happens to be int, for example, then number types, num type will be the command int. So this is going to then put int on the input, and we'll try to convert input to an int. So we're going to try to do that conversion, and if that doesn't work, then there's 2 kinds of errors we can get. We can get the value error from before, and then we have to check, are we looking at a float or an integer, depending on what kind of error we're going to report. So if it's a float, we say, well, you must input a float, and if it's an int, you must put an int. There is another error we can get, and that is if somebody passes in, like I'm going to do, a complex num type that is not in this dictionary, that's going to return a key error. So that's not a valid key. And in that case, we're just going to print out the num type that somebody passed in and say, that's not a valid number type. And we do something called a raise. Raise means, hey, my procedure is not handling this error, so it actually keeps the error around. So when this code finishes, it's going to come back to where it was called here, and that error is still going to exist. So that key error will still exist back here. It's not been handled, and we'll come down to accept key error and return back none. These other errors here actually are handled, and so we will come back here. There's no more errors. The error flags for value error are reset here. So when we get back to here, there is no value error. Hopefully that makes sense. So the Python language internally keeps track of what exceptions or what errors have occurred, and when you handle that like this, it says, okay, we're done, and clears those out. But in the case when you do a raise, it says, oh, you're not done. And so it keeps that kind of error hanging around. Maybe that's clearer or less clear. I don't know. All right, so let's try this. We're going to run validating input 2. And before we get anywhere, we get complex is not a valid number type, and we print out none. So what happened? Well, we passed complex here. That came in as the num type, and we tried to input that number, and we tried to return number types num types. So in this case, we went up to number types and looked for a key called complex, and it's not there. So before you even got to input the string, it failed with a key error. It printed out that number type complex, it capitalized it, so it made a first letter capitalized. It's not a valid number type, so that's here. Then we raise the error, which means that we come back here where we tried to input number, and it says, nope, we have a key error. And so on key error, we are going to return none, and that's where the print none comes from. We printed out input number type, and in this case, it was none. So let's change this to something else. Let's change this to an int, and now we can run, and actually it'll ask us to input a float. So at this point, we've called this with an int. We go to input number, and it's trying to do the input number once. So now we are right here. The key num type is int. So number type's int on that key is this value, which is a command, and it's going to try to convert our input to an int. So if I put in 2.3, which is a float, then that's going to generate a value error. It's going to come down here and say, oh, the num type was int. You must input an integer, and it's going to return none. When we get back here, then the error is going to have been cleared, and so here it's going to try this. It's going to get a none, and it's going to put us back up into the while loop. So notice the difference here. When I get a none back, then I just come back up to the while loop, whereas before with the key error I actually did a return which exited out of the while loop. So it's going to put us back into inputting a float. Whoops, I say input a float, but I meant int, so this is not very good programming. I didn't change both of those. Well, okay, so we'll actually input an integer. We'll input a letter, and again, the same sort of thing happens. We get an error up here. It's handled by outputting, you must input an integer. Although I keep saying float. So let's input an integer and end this. And I'm going to change this to float. These two things should be should coincide with each other. So let's run this again. Input a float, and now it says you must input a float like it should. So this error message is actually generated by whatever this data type was, and because I had the int before, it was saying you must input an int. So we'll input a float in this case, and we're done. So here's a neat little trick. If you ever want to call a command, but you're not quite sure what the command is, like I'm not sure if I want to do an int or a float, you can actually make up a dictionary like this and key it and call it using the dictionary. And then the other thing we learned in this one is that you can raise an exception. So you can do some work with the exception in your procedure, but then say, I want to raise that. I don't want to clear that exception out because other procedures may want to deal with it also.